End user. So very much I think of not the application, but their use of it. These tools are deployed in knock environments, and there's a lot going on. And a lot of times the engineers and the personnel are doing their best to keep their eyes on the screens and make sure that service is uninterrupted. So we use a lot of WebNMS's alarming capabilities. Things light up very well. We send emails, make sound alarms with, and we can correlate the most important thing is we can correlate very complicated outage scenarios into simple user interface displays. So the team is spending more time on actionable tasks rather than trying to troubleshoot, and that's automated in software using WebNMS. So we definitely have looked at the typical technology stack. IBM Tivoli has a huge suite of tools for monitor and control and everything in between. Hewlett-Packard, HP OpenView, they have a number of tools as well. There's a number of open source tools as well. When we compare all of them, honestly the strongest capability that we found is that WebNMS was the easiest to learn within days to weeks time. And out of the box it did quite a bit for us, especially in the areas of fault management. But everything from the support staff to the actual software development guides and the way the software is orchestrated, it's a lot easier to get new engineers up to speed on developing. When I compare that with the learning curve of some of the other tools, it's very challenging. Not even knowing what tools from certain suites to pick for fault management or configuration, provisioning, performance. I think WebNMS gives us the best bang for the buck all in one package. Yes, we spent quite a bit of our post-delivery time integrating with other systems, so particularly other monitor control systems for satellite networks, or even some of the network elements that are being controlled through non-WebNMS domain. We integrate with them. We share alarms and traps so that the displays are consistent. One display is not green while the other one's lighting up and everything's on fire. So everything from trap and alarm forwarding to, in fact, the web interface has been very powerful for us. WebNMS has the ability, fits very nicely, products like Chrome or Firefox, where it's in a package of other tools that are just maintained in separate tabs. So learning curve, again, is very important. Engineers can flip back and forth in a browser, and it's much more easily engaging to them than launching these really big software products that look so different. The operating systems, we try to be very cheap. We want to spend as little money as possible on hardware and software. For the hardware stacks that we use, oftentimes the deployment's already out in the field and we're doing major upgrades, so we don't have the luxury of buying big footprint hardware platforms. So having said that, 2 to 8 cores, we are getting great performance. We have networks that talk to up to a few thousand devices, and performance, CPU utilization have been the least of our concerns. Oh, database. We actually use MySQL, and we try to stay very light on our database activity. We find that performance has been great. The implementation of Hibernate in WebNMS has been extremely good. Everything from the learning curve of development to performance. We look at some trending that we've seen on just the use of an open source database that's free, using an open source technology like Hibernate, and the use of CPU and the volume of database consumption. We're talking 20 to 30% after 6 to 8 months' time. And we take in quite a bit of data. And that has not been of major importance to us in terms of performance. We're very happy with how it's performing. Operating system, we've been using, again, open source, CentOS. We actually have a couple of deployments just testing it out on Ubuntu. And so far, any Linux distribution we put WebNMS on has performed like a champ.